Okay. Hello everyone, my name is Adriana. I'm a final year chemistry student, and today I will talk about the applications of chemistry in cultural heritage, and I will explain why chemistry is important when we're trying to study cultural heritage. So in this picture you can see an image of Perkin's mauveine, so a piece of silk dyed with Perkin's mauveine, which is the first synthetic dye, and I will also talk about it today. Okay, so chemistry is defined as the study of matter, but it's a very vague sentence. So what does a chemist really do? And the truth is that chemistry is very versatile, but very complex. So a chemist can do different things. There are environmental chemists, biochemists who decide to become astronauts, forensic chemists, medicinal chemists, and finally conservation chemists. So in this picture you can see chemists analyzing a fresco with a portable instrument. So we tend to divide art and science. We tend to think about art and science as two different fields. They don't work together. You can either be creative or rational, but actually they can be compatible, and art can be useful to science, science can be useful to art. And this is exactly what conservation chemistry tries to do. So combine art and science. Conservation chemistry is a relatively new research field. It only goes back to about 40 years, and at the beginning it was quite difficult to convince proper scientists that this is a branch of natural sciences. So it was difficult to get funding to do research. But the truth is that it's not just for art lovers, so it's not art history. In a way, it is like material science, because the number of objects and the number of artifacts that needs to be analyzed is really endless. So a conservation chemist needs to understand and interpret the artifact, so what materials were used, how was it made, preserve it, so where should the artifact be stored, and finally conserve it. So a chemist would have to work together with a restorer to find the best materials to treat the artifact and to treat it without altering it. So in these pictures you can see there's a vase or a painting, but really a conservation scientist could analyze human bones, fossils, frescoes, but also the artistic materials that are used for these objects, to create these objects. And so like pigments or dyes, and that's what I focused on. So I focused on the first synthetic dye, which is called mauveine. This dye was really discovered by accident in 1856 by an English chemist called William Perkin. Perkin was really trying to do something else. He was trying to synthesize a drug used to treat malaria, but what he synthesized was mauveine, actually synthesized, he obtained some black solution. He was trying to wash it away, and then he noticed that it turned, when he added methanol, it turned purple. So he really liked the color, and he decided to stain a piece of silk. And after a few days, he noticed that the color was not fading away. It was very bright, very purple, very, very nice color. So he was able to open the first dye factory. And this really revolutionized the chemical community, because chemistry was still seen as kind of alchemy, so very mysterious. They couldn't really make money from chemistry. They couldn't really understand exactly what was going on. Sometimes today we still can't understand what is going on with chemistry. But yeah, so he proved to other scientists at the time that chemistry was useful, and they could invest money, basically. So this not only had an impact on the scientific community, but also on society. So what they would use to dye clothes at the time were natural dyes. Natural dyes are not very light or wash or pollution resistant. So they would dye clothes with these dyes but then the colors would just fade away over time. And what they were able to do after mauveine was discovered and after they were able to synthesize more dyes was have very bright colors. So for my project was an outreach and teaching project, and we decided to bring conservation chemistry to an advanced higher chemistry class. We wanted to use some objects, some samples that had mauveine in it, but it is obviously very difficult to just get samples with a very prestigious dye, until I found out that mauveine was used in some Victorian stamps. So as you can see, these stamps are all purple. They're all from Victorian times, but well, most of these you could find them for a few pounds on eBay, and one of these, well, you could probably find it for up to £100 on eBay. And the reason is that not all these stamps were dyed with the same dye, and one of these was dyed with Perkin's mauveine. So we divided the class into 3 groups, and we gave them a set of information, a package, and they had to, well, they had to work in teams, and they had to match the information to the right compound. So these are just purple dyes that were used or thought to be used for the stamps. So crystal violet was, it belongs to the violet family, and it was thought to be used for a long time, but actually very recent papers prove that it was not used. Carminic acid is actually a natural dye, and it's actually red, but they made it look purple, and it's used in the penny lilac stamp. Pseudomauveine is very similar to mauveine, but not exactly. It was synthesized by one of Perkin's colleagues, and it was used for the 6-pence stamp. But actually, Perkin's mauveine was used also for a 6-pence stamp, and this is visually really the same as this one. As this one. The difference is that there's an hyphen missing between 6 and pence, and there's an hyphen here between 6 and pence. So chemists, like, we only know this because chemists analyzed all these stamps, all these issues from different years, and they could prove that this is the one that contains the original mauveine, and this one is not the original one. So what they were also able to prove is that mauveine is actually a mixture of different compounds. So it's not just one molecule, but it's actually, there are a total of 12 molecules, and these are the main ones that give color to the dye. As you can see, they're really very similar. The only differences are these groups that are attached to the main part of the molecule. So the project was quite successful because the students didn't know about conservation chemistry, and they were actually very excited to learn about it. And they also were excited to learn about the story of Perkin. So this is exactly why we need chemistry to analyze cultural heritage. And it is also important to say that Perkin didn't really have any kind of advanced techniques, so he couldn't really confirm what he was doing. So it was only in 1994 that chemists were able to prove what the structure of mauveine was. So yeah, that's why we need chemistry in cultural heritage. Thank you very much. I also brought some stamps. I'm just going to leave them here if you want to have a look later. Any questions?
Hi, I just wondered, was Perkin only able to dye in purple, or was he able to dye in other colours as well?
The first one was purple, but then he opened a dye factory, so they were producing other colors. Yeah, I think he was the first one to produce a synthetic red. Yeah, but then all other factories opened in Germany and in the rest of the UK. I think there was a very important one in Glasgow as well. So yeah.
What's the difference between mauveine and pseudo-mauveine, and why did his colleague make it?
So Caro was Perkin's, one of Perkin's colleagues. I think they were just trying to synthesize different kind of dyes, different kind of shades. So I think pseudo-mauveine is probably not as bright as mauveine, but the main difference is probably methyl groups on the molecule. Very, very similar though, very, very similar.
I have a question from someone in the audience who has asked, do you know of many other situations where chemists have done similar forensics on artworks, and do you have a favourite mystery that was solved?
Oh, okay. So I've read this very recently on Chemistry War, which is the magazine for the Royal Society of Chemistry. So in Florence, I believe, they were trying to, they had a drawing that they thought was made by Michelangelo, but they couldn't really confirm it because there was a piece of sticky tape on the drawing. And also, they couldn't really remove it because they were afraid that it was going to damage the drawing. So they used some gels to soften the sticky tape, and they removed the sticky tape, and it showed the signature of Michelangelo. I really love that. It's amazing.
Okay, well, if you'll join me in thanking Adriana for a fantastic first talk.
Thank you.